Today we'll be presenting an ecological analysis of Point Pleasant Park in Halifax, Nova Scotia, presented by myself, Meghan, Kiana, and Noah. In 2003, Hurricane Juan hit Atlantic Canada with winds around 165 kilometers per hour. This Category 2 storm caused massive devastation, including property destruction, power outages, and great amounts of tree damage to Halifax. Point Pleasant Park was one of the main locations that was greatly affected, as it was measured that approximately 70% of the park's trees were knocked down from the storm, meaning that a majority of the pre-existing species were wiped out. Over the years from 2004 to present day, secondary succession has occurred, meaning that there has been a gradual change in the ecological community after a disturbance. Over the past 20 years, data was collected by multiple classes of Biology 2060 at Dalhousie University, where they measured tree species richness, density, and evenness in each biological site labeled 1 through 6. By collecting these results, we were able to see how much the forest community has changed and adapted after a massive disturbance. The objective for this presentation is for you to obtain an understanding of what ecological succession is and how it can be used when measuring species richness, density, and evenness after a disturbance throughout time.
To collect the data we are presenting, a few different types of equipment and procedures were used to collect and analyze the data. To collect the data, average diameter at breast height, or DBH, was found by using a diameter tape, which measures the length around the cross-section of the area of the tree at 1.3 meters above the ground. The tree density per species was also found at each site. This data was analyzed by finding the regression analysis on the total density, average DBH, species richness, Shannon diversity, Pelu's evenness index, and the dominant species Picia rubens and Acer rubrum. The degrees of freedom and the regression results were also found. Linear regression was chosen because it allows us to quantify long-term directional changes in each community metric over time and evaluate the strength of the relationship between year and ecological variables. The 6 sites where the data was collected from were the most impacted locations in Point Pleasant Park. Site 1 is located at the intersection of Cambridge Drive and Ogilvie Road. Site 2 at the end of Pine Road where it meets Fort Road and Ogilvie Road. Sites 3 and 4 are located on Heather Road, where Site 3 is more northern than Site 4. Site 5 is located on Sailors Memorial Way, just north of the Sailors Memorial. And finally, the location of Site 6 is on Arm Road north of Purcell's Landing.
The overall forest community has changed into a more diverse and multi-layered ecosystem. Prior to Hurricane Juan, the forest consisted of mostly softwoods. However, after years of conducted research, it seems the forest has taken on more of an Acadian ecosystem, with a mixture of conifers, broadleaf species, and an increase in native species such as red spruce and balsam fir. Also, due to the hurricane uprooting so many trees, an initial effect was a thinner canopy that played a part in what types of plant growth there was, as the surrounding environment had changed drastically. The reason why there has been such a big change is because a restoration effort was put in place in order to make a stronger and highly diverse forest that included native species that would hopefully be able to withstand some natural disasters in the future. And with the restoration, the open canopy allowed for more sunshine to touch the forest floor, giving a faster rate for reproduction and new species growth. It can be predicted that as the forest moved towards its climax community, a more mature, complex, and highly diverse ecosystem will be created. This is because these results demonstrate a stable ecosystem that has a constant growth as it has reached equilibrium with the surrounding environment.
Hi, my name is Noah Nukosak, and I'm here to present results too from in our paper because I know you really want to hear them. All right, so Hurricane Juan happened in 2003, and in 2004, people went to collect data after this major disturbance. And what they found is that in 2004, red spruce trees, they found 13 red spruce trees across plots in Point Pleasant Park, and they found 0 red maple trees. However, in 2024, red spruce trees were 44 and red maple trees were 158. So that's a big change, a switcheroo, if you will. So, um, if we look at the figures and speak the language of biology, we will see that, or statistics, we will see that red spruce had a rising slope of 0.35 and red maple had a slope of 2.24. So you can see red maple is climbing up at a much faster rate.
Shannon diversity increased over time from 2004 to 2024, which is shown with a positive regression slope of 0.0555. In earlier years of the study, there were low diversity values, which shows a simplified community because of Hurricane Juan. Over time, the diversity values became consistently higher, typically between 1.2 and 2.0. The moderate R-squared value of 0.3262 shows that even though there is a variation from year to year, there is an overall positive trend in community diversity. Species richness increased steadily from 2004 to 2024, shown by the large positive slope of 0.4823 and the R-squared value of 0.577. Early years of the study show low richness, which later years regularly had 10 to 14 species per plot. The changes in red maple and red spruce densities reflect the forest successional pathway after the major disturbance in 2003. Red maple shows a rapid increase over time, which is expected for an early to mid-successional hardwood that quickly establishes in high light and disturbed conditions. In contrast, red spruce increases much more slowly, consistent with its role as a late successional shade-tolerant conifer that only begins to reestablish once canopy structure returns.
Okay, so now that we have the results, at least let's think about it. So, red maple, why would it grow faster? Well, after Hurricane Juan knocked over so much of the surrounding forest, um, red maple is a species of tree that can take advantage of increased sunlight that may have been denied to it in the past prior to the hurricane. So, red maple was able to grow much faster. And what other concepts can we think about? Well, in those 20 years, total density increased, species richness increased, and also Shannon's diversity index went up over those 20 years. And what we believe is that red maple growth will eventually level off and plateau, and that red spruce tree will increase in numbers, similar to how it was prior to this major disturbance in 2003.
The increase in the Shannon diversity reflects secondary succession after Hurricane Juan, which removed much of the canopy and reduced initial species diversity. In the years after the hurricane, multiple tree species reestablished themselves in the plots. The missing years correspond with the additional hurricanes that may have altered the trajectory. Shannon diversity will likely level off as the forest matures because climax communities tend to have stable but not rapidly increasing diversity. Together, these trends show a forest currently dominated by fast-growing maple and gradually shifting toward conditions that will eventually favor red spruce as the system moves towards its climax community. As species richness increases, the forest recovers from severe canopy loss and multiple tree species were able to colonize that open space. They benefited from high light availability and reduced competition. Over time, both red maple and red spruce entered the community, increasing overall richness. As the forest approaches its climax state, species richness is expected to stabilize because close canopy conditions and stronger competition limit new establishment. Thus, richness will plateau at a moderate level, much like mature Acadian forests.
So, what can we think about this as biology students after all of this information that we've been going over for the past little while? We believe that the Point Pleasant Park is in mid-stage succession. We have seen that the species richness and Shannon diversity increase, which means that the forest is increasing in complex structure, and that total density is still increasing, which means that there is light and available in the forest for other species to grow. Now, this is an urban forest, so we have to think about human effects on it, and some of those effects could include changes on soil chemistry, and other effects could include human interference, like growing, like cutting pathways or trimming trees back. And we also must consider the Mi'kmaq nation and how we can use it to approaches of interconnectedness to for sustainability. We would like to acknowledge the people who made this project possible, such as lab professor Dr. Joanne Zagoras, our teaching assistant Stephanie Frith, and the author of the lab manual, Alison Schmidt, also the students and staff, and BIOL 2060, who worked to gather the data from 2004 to 2025.